Then wear appropriate protective clothing. Your clothes should cover your legs to knees. Shorts are not appropriate for the laboratory. Lab aprons can be used to protect good clothing. Loose clothing should not be worn because it may dip into chemicals or fall into a flame and catch fire. Wear shoes that cover your feet. Sandals and open-toed shoes do not protect your feet from broken glass that is frequently found in the laboratory. Inside the chemistry lab, we usually use the glassware for preserving the chemicals, for handling the chemicals, for sometimes heating up the chemicals and making the reactions of the chemicals inside the chemistry lab. We use glass apparatus. There are two reasons why we use the glass apparatus. The first one is glass is usually inert in contact with other chemicals. That means it does not go for any chemical reaction. Usually, does not go for any chemical reactions with the other chemical substances. And another thing is transparency. As the glass is transparent, so we can easily identify any kind of changes occurring inside the apparatus or inside the container. Also, leather shoes protect your feet from chemical spills. Canvas shoes do not. Do not apply cosmetics, eat or drink in the lab. These activities are ways by which can accidentally ingest harmful chemicals. Do not taste any chemical. Pour from the large container to the smaller one. Usually, we buy the chemicals from the market or commercially in a very large container. Sometimes the liquid chemicals are bought in 5 liters container, 2 liters container, and sometimes 1 kg or 2 kg containers. If we want to use the chemical, we need to transfer the chemicals from the large container to the smaller one to make easy transfer to easy handle the chemicals. Add acid to water. It is necessary because sometimes the concentration of acid is not suitable for carrying out some of the experiments. That's why we need to dilute the acid. We need to decrease the concentration of acid. And in that case, we have to add the water to decrease the concentration of acid. So whenever the situation is required, we need to add acid to the water, but we should not do opposite. We never need to add water to the acid, otherwise it may cause fire. Hold your hand over the label while pouring. Whenever we are transferring the chemicals from one apparatus to other apparatus, we have to hold the container or the apparatus in this way. Work with volatile chemicals under a fume hood. Volatile chemicals usually which create the steam or the fume at room temperature. And if we want to handle those sorts of chemicals, we have to use this type of fume hood where there is a draft fan which can draft away, which can drag all the chemical vapors outside the laboratory. So this is called the fume hood, and usually the toxic materials, usually the volatile materials, can should be handled inside this fume hood. Crack glassware for check glassware for stars or crack. As I told, most of the apparatus inside the laboratory, chemistry laboratory, are glassware. And before selecting any of the glassware, we have to check whether there are any crack or any star mark. Heat test tube at an angle directing the opening oppositely to you and other people in the laboratory. Handle hot glassware with gloves or beaker tongs. First light the match, then turn on the gas. In the laboratory, the Bunsen burner is one of the source of heating the chemicals, and it has an open fire flame. So whenever we want to use the Bunsen burner, we need to first lit the match, then we need to turn on the gas of the Bunsen burner. Do not smell any chemical directly. Sometimes the smell will help us to identify the chemicals. If it is necessary, then we should not directly smell the chemical. Rather than we can draft the fume over the container by our hands indirectly, we can smell. If absolutely necessary to smell, use your hand to fan the vapor to your nose indirectly. Do not pipette solutions by mouth, because a pipette is a process through which we can transfer certain amount of liquid from the large container to the small container. And in that case, we should not do it by our mouth, because it can enter inside our mouth and can make injury. That's why we have to use the pipette filler to inlet and the liquids inside it, and also it will help us to transfer safely. Wash your hands with soap and water before leaving, as we need to handle the chemicals inside the laboratory. And sometimes we, after the experiment, we may go for the canteen for having our food. So to make sure that we have removed all the chemicals attached to our hands, and that's why we need to wash hands with soap and water very carefully. This one is very important. Know the hazards of the materials being used, because most of the cases we do not know how the chemical will behave with us, how the chemical will behave with the environment. Now, because in the chemistry laboratory, we wasted a lot of chemicals to the environment. That's why we need to make sure that the chemicals that we're handling will be harmful for us, harmful for the environment, and harmful for the other animals. And all this information will be found in the MSDS. This is called the Materials Safety Data Sheet. And sometimes it is also called the SDS only, Safety Data Sheet. So whatever it is describing all the properties, physical properties, chemical properties, and also the hazardous properties and the toxicological information on the human health, animal, as well as the environment. So whenever we are handling any of the chemicals, first of all, we need to find out all the information of that chemicals by studying this MSDS or SDS, Material Safety Data Sheet or Safety Data Sheet. Know the hazards of the material being used. Read and reread labels carefully to make sure that you are using the right chemical, first thing. And second, know how to interpret data from an MSDS. I have some examples of MSDS, and also you can download the MSDS from net free. Tieback loose here, dangling here can fall into the Bunsen burner and catch fire, or can fall into chemical solution. The safety equipment should be learned, and where the location and how to use. Never remove any chemicals from the laboratory, because most of the chemicals are corrosive, and if they contact especially to the metals, it can cause the rusting and other corrosion. Do not work alone in the lab. In the case of a problem, you may need another person to prevent injury or even save your life. Usually, this is not allowed in the laboratory. If you wanna work, you should ask someone to be with you, because in case of any emergency, the other person may help you. Remember that the lab is a place for serious work. Careless behavior may endanger yourself and others and will not be tolerated. Safety rules to be strictly followed by all the students. Safety for the chemicals, safety for the equipments. Here I would like to share a demonstration with you. Please wait a bit. I'm going to prepare that for sharing.
Chemistry lab is different from most other courses. Here you gain new knowledge by doing things, not just reading about them. You'll spend much of your time in chemistry lab working with equipment and techniques that are new to you. They can be dangerous if you don't adhere to strict safety procedures. But if you start with safety by following the rules, paying attention, and using common sense, you can work with confidence that you'll be safe in the chemistry laboratory. And you can have fun at the same time. Handling chemicals safely means following rules designed to keep them from contacting your skin and eyes, or someone else's. One important safety rule is always use small containers that you can control easily. Ignoring this rule can cause accidents. If you have an accident, always inform your teacher. Pouring from small containers is far safer. Accidents can also happen when mixing chemicals.
Is this okay?
Looks fine. You can go ahead and get started.
Okay, thank you.
To be safe, only mix chemicals when your teacher says to. Read the instructions for the experiment all the way through first, before doing anything. Read and reread labels before use to make sure you've got the right chemicals. Note the concentration and the hazard warning. Accidents can happen when the wrong chemicals are mixed together, or when the right chemicals are mixed together in the wrong way. Make sure to follow your instructions exactly. For example, suppose you have to dilute concentrated sulfuric acid with water. You might think you could mix them together any way you wish. But there's an important rule for diluting concentrated sulfuric or phosphoric acid that should always be followed. Add the acid to the water, never the reverse. Remember it by the initials AA, add acid. Watch what happens when you don't follow this rule. This is water added to acid. The acid boils, and it can splash out of the beaker. When acid and water are mixed correctly, there's less danger. Acid is poured from a graduated cylinder or beaker down a stirring rod into the water. Whenever you work with chemicals, there's a chance of spills. A work tray under your setup will help contain them. Always move carefully when handling chemicals. Keep coin-top stoppers between your fingers, not on the bench where they can pick up contaminants. Hold bottles with your hand over the label and replace stoppers immediately. Covering the label keeps drips from blurring it or getting on your hands. Set bottles out of the way when you're finished so they won't get knocked to the floor. When handling chemicals, always keep them away from your face. Never taste anything to see what it is, and don't touch it or smell it directly from the bottle either. Small amounts of some chemicals, even vapors, can harm your eyes, mouth, and nasal membranes. There's a safe way to smell a chemical indirectly, if your teacher gives you permission. Hold it away from your face and waft the vapors to your nose. That way you won't get a strong whiff of them directly. Certain chemicals give off vapors. They're called volatile chemicals. You should work with harmful volatiles under a fume hood. Your teacher will tell you what these chemicals are. Chemicals should be kept pure and uncontaminated. One way to prevent contamination is to use only clean glassware. Another way is to only pour out of a reagent bottle. Never pour anything back in, even excess chemicals you haven't used. It's better to waste the excess than to risk contaminating the entire bottle with particles from around the lab. After measuring out a reagent, you'll often have something left over. Instead of pouring it back in the reagent bottle, dispose of it in the proper waste container. When drawing out chemicals with a pipette, don't use your mouth. Use a bulb or pipetter. You can collect the exact amount you need and never have to come in contact with it. At some point in your laboratory work, you'll probably spill something. You should report spills immediately. Stay away from the spilled chemical and let your teacher clean it up. To keep a large spill from spreading, it's barricaded with an absorbent material such as kitty litter. It's then either mopped up or covered over completely with the absorbent. The absorbent and chemical can be swept up with a broom. What's done with the residue depends on the type of chemical it contains. Your lab should have a container for each type of waste. Don't throw waste chemicals down the sink unless your teacher says it's all right. Waste paper that's not contaminated by chemicals goes in a conventional trash can. And broken glassware goes into a separate container. The last chemical handling safety rule to keep in mind is to clean up when finished. Glassware should be thoroughly scrubbed and rinsed so it's as clean as possible for the next experiment. Liquid puddles or powders left behind on a lab bench can get on the next person's clothing or skin. Wipe them up thoroughly and throw the paper towels away in the proper container. And clean chemicals off your hands before leaving. There may be invisible chemical residues that could damage your skin or contaminate your food the next time you eat. Work with small containers. Mix chemicals only when your teacher says to. Read and reread chemical labels. Read instructions all the way through first. Use a work tray if your lab has them. Move carefully and deliberately when handling chemicals. Add concentrated sulfuric or phosphoric acid to water. Hold coin top stoppers between your fingers while pouring. Hold bottles with your hand over the label. Replace stoppers immediately. Keep chemicals away from your face. Work with harmful volatile chemicals under a hood. Keep chemicals as pure and uncontaminated as possible. Draw out chemicals with a pipette filler, never by mouth. Notify your teacher to clean up spills. Put waste in the proper container. Clean up when finished. The main heat source in most chemistry labs is the Bunsen burner. It produces an open gas flame burning at a high temperature. There's always the danger of an accident if it's not used properly. For example, it should never be used to heat volatile organic liquids that give off flammable vapors. These substances should be heated in a heating mantle or steam bath in a hood. But for most other substances, a Bunsen burner is an ideal heat source when used properly. There are several types of Bunsen burners, but they all have the same basic parts. The gas comes from an outlet on the lab bench. A rubber hose fits over the tip and over a similar fitting on the Bunsen burner. Most burners have a valve at the bottom to control the flow of gas. Air inlets control the amount of oxygen in the flame. A wing top can be placed on the burner to spread the flame out. There are several important rules to follow to use a Bunsen burner safely. First, check the gas hose for cracks. If you see any, get a new hose. Make sure the hose fits securely on the gas valve and on the Bunsen burner. The gas valve at the bottom of the burner should be open. You can light a Bunsen burner with a striker or a match. Open the gas line valve and light the burner. If the flame's properly adjusted, you can place the burner under your setup. When using a match, strike it away from you. Turn the gas on after the match is burning. That way, gas won't escape while you're striking the match. Light the gas from the side so the match isn't blown out. A yellow flame is too cool. Opening the air holes lets in more oxygen for combustion. Adjust the bottom valve if the flame is too large or small. The flame should be blue with a lighter inner cone. The tip of the inner cone is the hottest part of the flame. If the flame begins to sputter or flare, turn the gas off immediately. Also turn the gas off immediately if the flame goes out. Unburned gas escaping into the room could ignite and cause an explosion. Even when the burner seems to be working properly, if you smell gas, turn it off. Cracks or stars in glassware are dangerous. They can break open when it's heated. So before you heat any glassware, check it carefully for cracks or stars. Flat-bottomed containers are normally heated on a wire screen on a ring stand. Erlenmeyer flasks and other narrow-necked containers should be secured to the stand with a clamp. test tubes can be heated in a water bath. The water bath transfers heat slowly and evenly to the test tube and helps keep it from boiling over. You can also heat a test tube directly in the flame. Hold it at an angle while moving it back and forth to distribute the heat evenly. Aim it away from yourself and your neighbors in case it boils over. Only heat containers with openings. A boiling liquid changes to gas, which must be able to escape. Gas can't escape from a closed container, and the pressure that builds up can burst it. Be extra careful when working with heated equipment. Hold hot glassware in beaker tongs, never your hands. Remember that the wire, screen, and ring stand are also hot. If you don't have tongs, protect your hands with gloves designed for hot glassware. Keep them away from the flame. Handle everything as if it's hot if you've been using a Bunsen burner. Glass and metal look the same when hot as they do when they're cold. Heat volatile organics in a heating mantle or steam bath in a hood, not over a Bunsen burner. Check the gas hose for cracks. Make sure the hose fits securely on the gas valve and Bunsen burner fittings. Stand back from the burner while lighting it. Strike matches away from you. Turn on the gas after lighting the match. Turn the gas off immediately if the flame sputters, flares, or goes out, or if you smell gas. Check glassware for stars or cracks. Clamp narrow-necked containers to the ring stand. Move test tubes back and forth through the flame at an angle while heating. Don't heat closed containers. Hold hot glassware in beaker tongs or hot mitts.